We're going to continue in day 2 of Math Week. And yesterday we kind of established the Cartesian or rectangular coordinate systems and the polar coordinate systems. Today we're going to start mathematically or arithmetically manipulating some of that information. In other words, we're going to take these vectors which go from the origin to a particular point in space, and we're going to add them together. And we're going to find out that it's really easy to do this in rectangular coordinates. So the first thing we're going to do is we're going to write down the ordered pair that we have for this point right here. And if I look at the x direction, I have 1, 2, 3, 4, 5. So I'll put down a 5 and 1, 2 in the y direction. So we'll put down 5, 2, and that will define that point, and it will define that vector or that arrow. This one over here, -1, -2 in the x direction, and in the y direction, 1, 2, 3, 4. Right? Does that make sense?
Yeah.
So if I were to look at these together and put them end to end, I would see something like that. And what I'm looking for is this. That represents the sum of those two. And the way I'm going to do that is I'm just going to write down the two things that we have, which is 5, 2 and -2, 4, and I'm just going to add them together. We're going to add them, we're going to add them. 5 plus -2 is 3. 2 plus 4 is 6. Which means that here I would be over 3 and up 6. I didn't draw those very well, but that's life. So what did we do?
First you determine the first vector, and then determine the second vector, and then you add it.
But when we added, did you notice that this represents x, that represents y? We added all of the x's together, and we added all of the y's together.
Right.
Right? So in a sense, we added apples and oranges. We keep them separate. The x direction stays separate from the y direction, right? But when I look at a number like this, I can't tell from looking at that number if it is an apple or an orange, because they are both just numbers. Okay? So I need to come up with a way that when I look at a number, I can tell if it's a y number or an x number. And we're going to use a letter of the alphabet to do that for us. And we're going to change the way we write these down. Instead of writing them down in terms of an ordered pair, we're going to write them down as a combination of an apple and an orange. And we're going to do that by making this 5 plus j2. And this one is going to be -2 plus j4. We're going to use the j operator to indicate that That is a y direction. Okay, why did we pick J? The rest of the world uses I for imaginary. We're using J because we in electronics already use I for current. So we use J to indicate that this is a Y value. No J indicates it's an X value. So now when we add all the J's together, we get J2 and J4. That adds up to J6, which is what we would have here. And the X values, the non-J values, 5 plus minus 2, gives us 3. So the answer then over here would be what? How would we rewrite this in terms of that format?
3 plus J6.
Right. 3 plus J6.
Now, would you keep the parentheses or just write it?
I can just write it at that point because I don't need the parentheses to indicate that it's an ordered pair. If I don't have those parentheses and I just see 3 comma 6, I don't know what that is. I'm probably going to think that somebody pressed the wrong button. It should be 3.6. But if I see it in parentheses, it's an ordered pair, X comma Y. Right? So this takes away that. You don't need to have the parentheses, but you're going to find out later on that we're going to end up using them because when we work with these in equations, we're still going to use parentheses to offset things and make sure that we do certain operations first. So you don't need the parentheses to define the point, but you will ultimately end up using them quite often. Okay? Any other questions on this so far?
Sounds fairly easy.
So adding and subtracting is pretty straightforward. We simply work with our apples and oranges, and we always add apples and subtract apples and oranges separately. We do not mix the two together. Okay? Now, let's talk about the other part of this arithmetic, which is multiplication and division. Multiplication and division is a little bit more abstract because we can't just draw a picture. We can't draw a picture and have it make sense. With putting the vectors end to end, it kind of makes sense that you're adding this one to that one. When we multiply, it's not going to be pretty. Uh, 5 plus J2, I think that's what we had before, yes?
Yeah.
Times what was it, minus 2?
Plus J4.
We want to multiply these now. Remember I said that you're going to spend a large amount of time, huge amount of time, converting between rectangular and polar? Did I say that yesterday? Probably 25% of all the work you do this quarter is going to be converting. Now we find out why. Because when we add and subtract these things, we do it in rectangular. we multiply and divide in polar. So the first thing we need to do out of the gate is convert these to a radius at an angle. I gave you some formulas yesterday to do that. Radius is equal to what? Square root of
Squared plus 5 squared.
5 squared plus 2 squared equals the square root of 29, which is what, 5.5 and a half, something?
5.38.
Okay, over here, r is equal to the square root of negative 2 squared plus 4 squared. And that equals 4 plus 16 square root, or the square root of 20.
4.47.
Okay, so let's go ahead and jot those numbers down here. 5.38. And this one was 4.47. Okay? Pythagorean theorem is what we used here. Shortly I'm going to show you how to do it the correct way using your calculator. What about the angle? The angle is equal to the inverse tangent. Remember we derived this yesterday from the SOHCAHTOA formula. Inverse tangent of y over x. In this case, that will be equal to the inverse tangent of y, which is 2, divided by x, which is 5. So I need the inverse tangent of 0.4.
21.8.
21.8 what?
0.
21.80 what?
Oh, degrees.
Degrees.
Okay.
Okay, let's see if you can get that.
2 divided by 5.
Then second function, tangent.
Okay.
Did it give you that?
Yeah, I didn't hit the equals.
21.8 degrees. Okay, so here's how we're going to represent this vector. We can say then that 5 plus j2 is equal to 5.38 at an angle of 21.8 degrees. You see how I wrote that with a little, if you're using the typewriter, you can use the greater than sign. That's how I do it when I have to type that somewhere. But you just draw yourself a little angle sign and you put the radius at that angle, and that's the way we will define in polar coordinates how a vector looks. Right? All right, let's do this one. The angle is equal to the inverse tangent of y over x, which is going to be equal to the inverse tangent of y, which is 4, divided by x, which is negative 2. So we're looking at the inverse tangent of negative 2. Can we calculate that?
Give you a negative 63.4.
What's that? What'd you get?
Same thing.
You got a negative 63.4, right? Here's why I have to teach you how to do this on your calculator. Okay? If you look at this, you'll notice that a straight line can exist at an angle of negative, how much was it?
63.4.
63.4. And if I look at that point, I have a plus and a minus x and y. Do you see that? So this is actually, this point right here is what? If this is negative 2, 4, then this must be 2, negative 4, is this point, right? This point is negative 2, 4. When I look at this, there's no difference between negative 4 over 2 and 4 divided by negative 2. It's still going to be negative 2. So there are actually two arrows, or 2 points, that for which this is true. Okay? What we have to do is either A, find a better way to do this, which we're going to do, or B, I know that this is wrong, this minus 63.4 is wrong, because the picture says it should be plus about what? 120-ish. Shouldn't it? Shouldn't that be about, there's 90 right there, and roughly another third of this portion. So that's around 120 degrees. What's 180 degrees away from 120?
60. Negative 60.
Minus 60. So that's where this came from. If this is minus 63.4, and we've moved it 3.4 more degrees this way, then this is going to be 120 minus whatever that would be, right? Yes? So that becomes a problem for us. So what is the real angle?
116.56.
One 116.56 is 180 degrees away from the answer that we got. And that's going to be an issue if you continue to use this method, because this method, there are 2 correct answers. And you have to mentally figure out from the picture that you have, it doesn't make sense that it's negative 60 degrees. It makes sense that it would be the 180 degrees away from that number. So this one, therefore, is 4.47 at an angle of 116.56 degrees.
So how did you get 116?
I got 116 by taking the answer, which is negative 63, and adding 180 to it. Because this is 180 degrees away from that point. So negative 63.4 plus 180, isn't that what you did? But we're going to take away that mystique here shortly, and we're going to find a way using your calculator to do this in like 1 step instead of 2 or 4, and you'll always come up with the right answer. We're going to find a way to separate where that negative sign is, and that will tell us which one of these 2 points is right. Okay? And we'll approach that as soon as we finish this example. But I want to finish our multiplication example so we can go through that process. So here we have 5.38 at an angle of 21.8 degrees, and here we have 4.47 at an angle of 116.56 degrees. Okay? And I need a little bit of space, so I'm going to get rid of this over here. Since we already have our answer. And I have, what was the first one? 5.38
3/8 at an
3/8.
angle of 21.8 degrees.
times 4.47 at an angle of 116.56 degrees. Okay? Here's what we're going to do. This is simple. Once you know how to do it. Multiply. Add. That gives us 5.38 times 4.47. And here we have 21.8 plus 116.56. What are we looking at, about 25?
24.05.
At an angle of
138.36 degrees.
(24.05) at an angle of, what was it, 138.36? Looks like that. Absolutely no bearing to the original numbers. Can't approximate what it's going to look like by looking at the variables and looking at the numbers like we could when we added them. We were able to actually physically draw the solution by drawing the two arrows head to tail. We can't do that with multiplication. Okay? The multiplication process is really quite simple once we have it in polar. All we have to do is multiply the coefficients and add the angles, and we're done. If we're dividing, what do you think we'll do? If we're dividing, instead of multiplying, we'll divide, and instead of adding, we'll subtract our angles from each other. Okay? Now, let's talk about how to do this in your calculator so that we can make this happen without having to worry about duplicity and arbitrarily trying to figure out angles. All right, here's what you need to get done in your calculator. I'll write down how it's done in the calculator I have, and you will have to figure out how to do it in the calculator that you have. Let's start out with 3 plus J4 because we know what that's going to look like. We did that one yesterday. 3 plus J4 looks like this. And I think we figured out that this is going to be 60-some degrees. I think it's actually going to be 56 degrees or so. But let's go ahead and do the conversion. Where's my green? Here's what I need you to enter in. Let's try this. Enter in 3. Hit the second function button, the green button. Then hit the X, Y button, which I think is right below it. You see the X, Y over on the left-hand side of your calculator there? It's green. It's not one of the main numbers. It's upper left-hand corner, somewhere in that area.
Should it go to 0?
I don't know.